Welcome to the new chapter. In this chapter, we are going to see how internal projects are identified. Okay, so this graph which shows the process of internal project selection. Now, the very first step is business issue brainstorming. Now, this happens at very top level, and the top management people sit for a brainstorming session with some data, with their experiences as well, okay, and they brainstorm the current business issues, and from there they identify the pain areas of the organization at that point in time. Now after that, what are those processes which are involved in those pain areas? Those processes are identified. After those processes are identified, throughput yield of each and every process steps is calculated. Now, what is throughput yield? Throughput yield is nothing but the percentage of units that pass through one operation in the first time right manner. I repeat, percentage of unit that pass through an operation with first time right manner. That is called throughput yield. In a simple explanation manner, I will explain you. If I am producing water bottles, I input 100 100 piece material of water bottle, and I found 98 water bottles which are without defect. That is called 98% throughput yield. Okay, I hope with this simple example you are clear about the definition of throughput yield. Then after calculating throughput yield, we identify the lowest throughput yield process step, and from that lowest throughput yield process step we dive deep, collect some data about the defects, and then we do a Pareto analysis to identify what are the top defect opportunities in that process, and according to that analysis we identify our project Y. We prioritize our project Y on the basis of Pareto analysis, 80-20 analysis, which we have already learned. Okay, so this is an entire process of internal project selection. Now we will look at the process in details from next slide onwards. I have given a simple process map. Now a process is something where input is converted into output, and in each process there are process steps. So look at this. This is called L1, level 1 process mapping, which is a macro level process mapping. Okay, you can see this. So there are 5 stages here: P1, P2, P3, P4, P5. So P1 is giving input to P2, P2's output becomes input to P3, P3's output becomes input for P4, and so on so forth. Okay, once you map this L1 process map, then you find out the throughput yield which we discussed. Now in this example we have taken a paint shop, a painting process. Okay, now in the painting process, as we have seen, P1, P2, P3, P4, P5, these are nothing but various process steps. In this case, P1 is surface preparation, P2 is pre-coating, P3 is lead coating, P4 is primer application, and P5 is at final painting process. Okay, and below each and every process the yield is given. For example, 0.97, or in other words 97% yield, which means if you input 100 pieces in surface preparation, 97% of the pieces would come out of the surface preparation without any defect in the first time only. That is called first time right, or FTR, or first pass yield. Okay, so now, so same with pre-coating. once we input 100 pre-coating pieces, 94 pieces would come out of pre-coating without any defect. So the yield of pre-coating becomes 94% or 0.94. Okay. Similarly, every process, for example, lead coating has 0.93, primer has 0.93, and painting has 0.60, which is 60% yield in this entire value chain. Now you will understand one major difference, that painting has got the lowest yield in this entire thing. Okay. Now if I want to calculate the complete rolled throughput yield of this entire cycle, what is rolled throughput yield? Rolled throughput yield is nothing but P1's yield multiplied by P2's yield multiplied by P3's yield multiplied by P4's yield multiplied by P5's yield. So the calculation is given below. So the P1's yield is 0.97 multiplied by P2's yield, which is 0.94, multiplied by P3's yield, which is 0.93, multiplied by P4's yield, which is 0.93 again, and the P5, the final painting process, which has the lowest yield of 0.60. So when we multiply all of this, we get 0.4732, which means when we put 100 pieces, we only get 0.47 or 47 pieces out in first time right manner, which is called rolled throughput yield. Okay. Now when we want to improve this entire efficiency of the cycle, we want to attack on the lowest yield process, which is painting. So going ahead, let's understand what do we do with this. So let's deep dive into painting. Now in painting, since it is a lowest yield process, we collect the data in greater details in painting. We find out what kinds of defects are regularly occurring, what is the frequency of the defect, and then we do a Pareto analysis of 80-20, where the defects are put on the x-axis, on the y-axis the frequency of the defects are put. So this 80-20 principle actually tells us what are those priority areas or priority defect opportunities we have, so that we can take care of that, we can improve upon that, and that becomes our project Y. Okay. So internal way of identifying projects, what we do is we first identify we brainstorm first what are the pain areas of the organization, and once we identify the pain areas, then in that pain areas we select which processes are having that kind of pain, and then each process we map them in L1 level 1 L1 process mapping, and then we find out throughput yield. We calculate the rolled throughput yield as well, which is multiplication of all the processes throughput yield. Okay. Then we take lowest throughput yield process, and then we do a Pareto analysis, 80-20 analysis, and Pareto analysis will give us priority areas of focus, which is defects, and that defect reduction becomes our project Y. This is a process of internal way of identifying. So one more example of the Pareto analysis given. Following Pareto is to identify the defects which are observed while processing checks in the reputed bank. So you can see this 78% actually you see are because of misspelled name and wrong account number. If you only consider these two defect opportunities or the defects, then you will take projects on these two. So these two become your projects, project Y. Okay. So these are the ways you can identify the projects internally.